So now we've got this, and you're like, what's going on here with the i's and the j's? This is just another way of writing -2, 3. So there are two ways of writing our little vectors. We can write it in this form with i's and j's, or we can write it in this component form like that. And both ways can be useful with whatever algebra you're using. Sometimes the algebra makes sense to do it this way, sometimes it's easier to work with that way. A lot of times I just change it right away. I kind of prefer this way for a lot of things we do, because I can kind of see that ordered pairishness of it. But that's, I wrote it over here, your unit vector. They always have a little hat on them, a little ray on them, is the unit vector in the x direction, so it just points to 1, 0. It's 1 long in the x direction, and j is 1 long in the y direction, like that. And so I'm just going to go ahead and rewrite -2i plus 3j as -2, 3. Do the same thing here. Going to rewrite this as 1 minus 2. So I can draw this here and say -2, 1, 2, 3. So it'll start at the origin and point to that point. And same thing, I could draw this 1, -2, so 1, -2. Start here, point to that point, and so I've got my vectors. Now when you see this notation here, this guy here means the magnitude. So the magnitude of vector u, which is a fancy, of u, which is a fancy way of saying the length of vector u. And sometimes you'll see it written like this. Some places will write it with 2 bars. That's okay too. 1 bar, 2 bar, that's what it means. And cool. And so we can find the length. Hey, I drew this, right? So I could draw a little like a little triangle and pull out my Pythagorean theorem. I know that this is 2 long, this is 3 long, and say that this guy here would be, I know that c squared equals a squared plus b squared. So if I call this guy c, c squared would be 2 squared plus 3 squared. So c would be the square root of 2 squared plus 3 squared. No big deal, right? Whatever that is. So it's going to be the square root of 2 squared plus 3 squared is the square root of 4 plus 9. So that length, that magnitude is the square root of 13. Not so scary. We know Pythagorean theorem. We'll do it again for v. So you could see it like that. You could also see it with double, in case you're looking at another book. So if I made a little triangle with v, that's 1, that's 2. How long is that? Well, if I do c squared equals a squared plus b squared, I'll have c squared equals 1 squared plus 2 squared. So c will equal the square root of 1 squared plus 2 squared, so square root of 5, right? So square root of 1 squared plus 2 squared equals square root 5. Now what you'll notice is that you're basically taking the x-coordinate and squaring it, and the y-coordinate and squaring it. Here we took the x-coordinate and squared it, and the y-coordinate and squared it. And so that's why you'll see the formula in a bunch of books that the magnitude of u, so if u is a comma b, then the magnitude of u will be the square root of a squared plus b squared. And this is just coming from Pythagorean theorem. If you forget what that means, draw your vector out and do a little Pythagorean theorem. We're going to be okay. We don't need to memorize this formula. I remember having so many formulas put to memory when I was studying this stuff, and because I thought that that was how I learned best. And as I tutor, I'm realizing, oh no, it's much better to understand. So there we go. So that's that one. I guess I'll finish off with this guy here. So again, you just kind of use the bars as like a grouping symbol. So we're going to go ahead and do 2 times u first. So I'll do 2, and vector u was -2, 3. So that should be, I can go ahead and distribute a scalar, -4, 6. And I'll just go ahead, and because I'm convinced that it's the Pythagorean I'm using, I'll do -4 squared plus 6 squared. I'll go ahead and use my shortcut now that I've proven it. So that'll be 16 plus 36. And so that'll be the square root of, is that 52? Which you could simplify if you wanted to. 52, so that's going to be 2 root 13. And that would be the length of 2u. So now you can play with it if you wanted, right? Draw 2u and find that length. Just play with them, make sure it works. Cool.